Constraint optimization. Constraint optimization is a method used to determine the maximum and minimum values on a surface represented by a two-variable function z is equal to f of x and y. To find the maximum or minimum value of f of x and y subject to the constraint g of x and y is equal to 0, we're gonna use the methods of Lagrange multipliers. So the first step is we're gonna form a new function called the Lagrange function, which is f of x, y, and lambda is equal to f of x and y minus lambda multiplied to g of x and y. The variable lambda is used as Lagrange multiplier to find the maxima and minima of a function. The next step is to find the first partial derivatives of f with respect to x, f with respect to y, and f with respect to lambda. Then solve the system by equating it to 0. F of x, f sub x is equal to 0, f sub y is equal to 0, and f sub lambda is equal to 0. So example number 1. Find the maximum value of the given function a of x and y is equal to xy subject to the constraint x plus y is equal to 20. We all know that x plus y is equal to 20 is equivalent to x plus y minus 20 is equal to 0. So solution, the first step is we're gonna use the Lagrange function. Let's substitute xy to f of x and y. So xy minus lambda multiplied to the given constraint, which is x plus y minus 20. The next is to find the partial derivative of the given function. So f sub x is equal to y minus lambda, f sub y is equal to x minus lambda, and f sub lambda is equal to negative the quantity x plus y minus 20. The next step is solve the system by equating it to 0. So y minus lambda is equal to 0 our equation 1. X minus lambda is equal to 0 our equation 2. And negative the quantity x plus y minus 20 is equal to 0 or x plus y minus 20 is equal to 0 is our third equation. So from the equations 1 and 2, it follows that x is equal to y is equal to lambda because y minus lambda is equal to 0 can be equivalent to y is equal to lambda as well as x minus lambda is equal to 0 magiging x is equal to lambda siya. So substitute natin yung x sa y in equation 3. Yung equation 3 natin is x plus y minus 20 is equal to 0 magiging x plus x minus 20 is equal to 0 na siya. So, x plus x is equal to 2x. Transpose yung negative 20 sa kabila, magiging 2x is equal to 20. Divide both sides by 2, magiging x is equal to 10. Thus, y is equal to x is equal to 10. The maximum value of the given function subject to the constraint occurs at 10 and 10. So, let's substitute the values na nakuha natin sa x and y. So, 10 times 10 is equal now to 100. Yun na yung maximum value niya. So, for example 2, find the maximum value of the given function f of x and y is equal to 3xy. Subject to the constraint 2x plus y is equal to 8. Then, we express 2x plus y is equal to 8 as 2x plus y minus 8 is equal to 0. So, for the solution, we form the Lagrange function of f given by f of x is equal to 3x, f of x, y, and lambda is equal to 3xy minus lambda multiplied to the given constraint 2x plus y minus 8. Then, find the first partial derivatives. F sub x is equal to 3y minus 2 lambda. F sub y is equal to 3x minus lambda. And f sub lambda is equal to negative the quantity 2x plus y minus 8. Then, we set each derivative equal to 0 and solve the resulting system. So, yung mga nakuha nating partial derivative, equate natin siya sa 0. So, for f sub x, magiging 3y minus 2 lambda is equal to 0, our equation 1. 3x minus lambda is equal to 0, our equation 2. And negative the quantity 2x plus y minus 8 is equal to 0, or 2x plus y minus 8 is equal to 0 is our equation 3. Then, solve equation 2 for lambda. Makukuha natin is lambda is equal to 3x kasi transpose lang natin sa kabila yung negative lambda para maging positive siya. Kaya yung nakuha nating value ng lambda is 3x. So, yung nakuha nating value ng lambda sa equation 2, substitute na natin ngayon sa equation 1, sa x. So, 3y minus 2 lambda is equal to 0. Magiging 3y minus 2 multiplied to 3x is equal to 0. Or magiging 3y is equal to 6x, or divide both sides by 3, magiging y is equal to 2x. And yun na yung equation 4 natin. Nagagamitin natin sa equation 3. Substitute natin yung nakuha nating value ng y sa equation 3. So, 2x plus y minus 8 is equal to 0. Magiging 2x plus 2x minus 8 is equal to 0. So, 2x plus 2x magiging 4x. Lipat natin yung negative 8 sa kabila, magiging 4x is equal to 8. Divide both sides by 4, magiging x is equal to 2. Yun na yung x natin. Para makuha naman natin yung value ng y natin, substitute lang natin yung value ng x na nakuha natin sa equation 4. So, y is equal to 2 multiplied to 2 is equal to 4. So, the maximum value of the function subject to the constraint occurs at 2 and 4. So, substitute natin sa original function, 3xy. So, 3 times 2 times 4 is equal now to 24. So, for example number 3, business, the beverage can problem. The standard beverage can holds 12 fluid ounce or has a volume of 21.66 cubic inches. What dimensions yield the minimum surface area? Find the minimum surface area. Assume that the shape of the can is a right circular cylinder. So, yung hinahanap natin naman ngayon dito is minimum, or we want to minimize the function. So, the given is S of h and r is equal to 2 pi rh plus 2 pi r squared, subject to the volume constraint. Pi r squared h is equal to 21, or pi r squared h minus 21 is equal to 0. So, solution, we form the Lagrange function S given by S of h, r, and lambda is equal to 2 pi rh plus 2 pi r squared minus lambda multiplied to the constraint pi r squared h minus 21.66. Then find the first partial derivative of S with respect to h is equal to 2 pi r plus lambda pi r squared. S with respect to r is equal to 2 pi h plus 4 pi r minus 2 lambda pi rh. First partial derivative of S with respect to lambda is negative the quantity pi r squared h minus 21.66. Then, for the last step, we set each derivative equal to 0 and solve the resulting system. So, 2 pi r minus lambda pi r squared is equal to 0, our equation 1. 2 pi h plus 4 pi r minus 2 lambda pi rh is equal to 0, our second equation. Then, negative the quantity pi r squared h minus 21.66 or is equal to 0, or pi r squared h minus 21.66 is equal to 0 is our equation 3. Since pi is a constant, we can solve the equation 1 for r. So, yung equation 1 natin is 2 pi r minus lambda pi r squared is equal to 0. So, eliminate natin yung pi r para yung matira lang sa loob is 2 minus lambda r. So, yung equation natin is pi r multiplied to 2 minus lambda r is equal to 0. So, magiging equal natin yung nakuha nating yung dalawang equation sa 0. So, pi r is equal to 0 and 2 minus lambda r is equal to 0. So, yung sa first equation, pi r is equal to 0, divide both sides by pi para yung matira lang sa kabilang, sa left side is r, kaya yung nakuha natin is 0. Same with sa equation 2 na nakuha natin, 2 minus lambda r, divide both sides by lambda, ay transpose muna natin yung lambda r sa kabila, divide both sides by lambda, ang matitira na lang is r is equal to 2 lambda. Since r is equal to 0 cannot be a solution to the original problem, we can continue by substitute natin yung 2 over lambda for r in equation 2. Yung equation 2 natin is 2 pi h plus 4 pi r minus 2 lambda pi r h is equal to 0. So, substitute natin yung 2 over lambda sa r. So, 2 pi h plus 4 pi multiplied to 2 over lambda minus 2 lambda pi multiplied to 2 over lambda multiplied to h is equal to 0. So, 2 pi h plus 4 pi times 2 over lambda magiging 8 pi over lambda minus 2 lambda pi multiplied to 2 over lambda magiging 4 pi h na lang siya kasi cancel out na natin yung lambda at lambda. Magiging 8 pi over lambda minus 2 pi h na lang siya kasi 2 pi h minus 4 pi h is equal to negative 2 pi h. Then, lipat natin yung positive 8 pi over lambda sa kabila. Ang matitira sa left side is negative 2 pi h. Tapos sa kabilang side naman, magiging negative 8 pi over lambda na siya. Divide both sides by negative 2 pi. Ang matitira na lang is h is equal to positive 4 over lambda. Since yung h natin is 4 over lambda and ang r natin is 2 over lambda, ibig sabihin yung h natin is 2r na siya. Kasi yung r natin is 2 lambda, multiplied natin sa 2, magiging 4 over lambda rin naman siya. Then next, isubstitute natin yung 2r for h in equation 3. So yung equation 3 natin is pi r squared h minus 21.66 is equal to 0. Substitute natin yung 2r, so pi r squared multiplied to 2r minus 21.66 is equal to 0. Then, 2 pi r cube, maging r cube na siya kasi 2r times pi r squared minus 2 pi r cube minus 21.66 is equal to 0. So, lipat natin sa kabila yung negative 21.66, magiging 2 pi r cube is equal to positive 21.66 na siya. Then, divide both sides by 2, magiging pi r cube is equal to 10.83. Then, divide ulit natin both sides ng pi, magiging r cube is equal to 10.83 over pi. Then, kunin natin yung cube root nila, magiging r na lang yun, yung r cube dati, is equal to cube root of 10.83 over pi, or approximately 1.51 inches. So, meron na tayong h na 3.02. Tapos, yung r natin na 1.51. So, the surface area is then a minimum and is approximately 2 pi multiplied to r, which is 1.51, and h, which is r ay 3.02 plus 2 pi multiplied to the 1.51 square, or about 42.98 inches squared or squared inches. So, ito na yung minimum value na nakuha natin sa given na problem. So, for example, for business maximizing revenue. Kim likes to create stylish stylish t-shirts, one style with a script X on the front and another with script Y on the front. She sells them to her math students as a fundraiser for her favorite charity. Kim determines that her weekly revenue is modeled by the two variable function. R of x and y is equal to negative x squared minus xy minus y squared plus 20x plus 22y minus 25, where x is the number of x shirts sold and y is the number of y shirts sold. So Kim spends 2 hours working on each X shirt and 4 hours working on each Y shirt, and she works no more than 40 hours per week on this project. How many each style should she produce in order to maximize her weekly revenue? Assume X is greater than or equal to 0 and Y is greater than or equal to 0. So solution, number of hours Kim works per week is a constraint. 2x plus 4y is greater than or equal to 40, or total din naman siya, hindi naman niya nagagamit yung full na 40 hours. Hanapin natin yung inequality ng original na constraint, which is magiging ano na siya, 2x plus 4y less than or equal to 40. So total, yung given is two variable function. Gagamitin natin yung theorem na extreme value theorem for two variable functions, kung saan yung if f of x and y is continuous for all x and y within a region of feasibility, guaranteed na siya na to have both an absolute maximum value and absolute minimum value. So yun yung gagamitin natin na theorem para dito sa problem 4. So, the constraints x is greater than or equal to 0 and y is greater than or equal to 0 allows to sketch the region of feasibility. Yan yung original na, ayun yung region of feasibility. So, yung sa first solution natin, find the partial derivatives of r with respect to x and y. So, yung r with respect to x natin is equal to negative 2x minus y plus 20. Nakuha natin siya sa original na function. Makikita natin sa taas yung tabi ng x and y axis. Then, r sub y is equal to negative x minus 2y plus 22. Then, solve the system for x and y. Magiging negative 2x minus y plus 20 is equal to 0. And negative x minus 2y plus 22 is equal to 0. Or, simplify na natin, magiging 2x plus y is equal to 20. And x plus 2y is equal to 22. So, to check along the y-axis, we substitute x is equal to 0 into the revenue function. So, substitute natin yung 0 sa x. So, r of 0 and y is equal to negative y squared plus 22y minus 25. Saan ko nakuha to? Sa original function natin. Revenue function na sa una, sa given na original function. So, yan yun. Then, the derivative is r sub y is equal to negative x minus 2y plus 22. Pag sinet natin yung expression na to equal to 0, ang makukuha nating value ng y is equal to 11. Pero, yung nakuha nating sagot is ignored kasi outside the region of feasibility siya. Kaya, yung try natin yung x-axis. Substitute natin into the revenue function. So, same sa ginawa natin, yung y naman ngayon yung palitan natin sa 0. So, r of x and 0 is equal to negative x squared plus 20x minus 25. Yung derivative niya is r sub x is equal to negative 2x minus y plus 20. Same yung nakuha natin na value ng y, pero feasible solution siya kasi may critical value siya. which is 10,075. Yun yung critical point. To check along the line, 2x plus 4y is equal to 40, gagamitin natin yung Lagrange multipliers to determine the possible critical values. Subject to the constraint, yung constraint is written as 2x plus 4y minus 40. So, yung Lagrange function na nakuha natin, na na-form natin is L of x, y, and lambda is equal to negative x squared minus xy minus y squared plus 20x plus 22y minus 25 minus lambda multiplied to the constraint 2x plus 4y minus 40. Then the second step is find the first partial derivative. So, L with respect to x is equal to negative 2x minus y plus 20 minus 2 lambda. L sub y is equal to negative x minus 2y plus 22 minus 4 lambda. And L sub lambda is equal to negative 2x or negative the quantity pala yan. May parenthesis 2x minus 4y plus 40. So, we set each partial derivative equal to 0. So, negative 2x minus y plus 20 minus 2 lambda is equal to 0 are equation 1. Negative x minus 2y plus 22 minus 4 lambda is equal to 0 are equation 2. And negative 2x minus 4y plus 40 is equal to 0 is our equation 3. So, solve natin yung equation 1 and 2 for lambda. So, yung equation 1 natin, negative 2x minus y plus 20 minus 2 lambda is equal to 0, magiging lambda is equal to negative x minus 1 half y plus 10. Kasi, pag linipat natin yung negative 2 lambda sa kabila, divide both sides, magiging positive na siya, i-divide both sides. Divide both sides by 2. Ang matitira na lang is lambda. So, 2 divided by x, negative x magiging negative 2x. 2 divided by negative y magiging negative 1 half y. Then, 20 divided by 2 magiging 10. Same with equation 2. Divide natin yung positive 4. Kasi negative 4 negative 4 lambda nilipat natin sa kabila, magiging positive 4 lambda. Divide both sides by 4, magiging lambda is equal to negative 1/4 y minus 1 half y plus 11 over 2. So, magiging, simplify na natin, magiging negative x minus 1 half y plus 10 is equal to negative 1/4 x minus 1 half y plus 11 over 2, or negative 3/4 x is equal to negative 9 halves. Or x is equal to 6 kasi divide both sides by negative 3/4. Ang matitira sa kabila x, then negative 9 halves divided by negative 3/4 is 6. So, we now substitute x is equal to 6 into the constraint 2x plus 4y is equal to 40 para malaman natin yung value ng y. So, 2 multiplied to 6 is equal to 4y is equal to 40. I mean, 2 multiplied to 6 plus 4y is equal to 40. Then, 12 plus 4y, plus po yung 2 times 6 plus 4y. So, 12 plus 4y is equal to 40. And, lipat natin yung 12 sa kabila. So, 40 minus 12, magiging 28. So, 4y is equal to 28. Divide both sides by 4. Yung y na nakuha natin is 7. Therefore, yung x natin is equal to 6. And yung y natin is equal to 7. So, yung critical point natin is 6, 7, and hanapin natin, which is, hanapin natin yung pangatlong critical point, which is 122. Paano natin nakuha? Substitute natin yung nakuha nating value ng x and y sa original function. So, negative 6 squared minus 6 times 7 minus 7 squared plus 20 multiplied to 6 plus 22 times 7 minus 25 is equal to 122. So, 6, 7, and 22. Therefore, Kim should produce 6 of the x shirts and 7 of the Y shirts to maximize her weekly revenue at $122. So, yun lang po.